What's up, everybody? Good news. I got that dentist appointment booked on Tuesday, day of our final. So if Brian is groggy or running around or on the Tuesday day of the final, I'll be at my dentist appointment. I see right here William helping out. Let's throw some 50 points. William, thank you so much. Throwing some help in the chat right there. So I have my interpretation 4 done. What is the function for creating an interaction? Trace helping out right there. I forgot in check regression is the linearity p-value, the overall p-value. That's the linearity of the overall model. Hey, what's up, our friend right there, Bulgarian friend, hanging out. Hey, Brian, would it be possible for you to go over number 5? I know you did a little yesterday, but I don't know if I need... Yeah, let's take a look at that. I should go... I'll probably go a good bit today. Like I said, my tooth is hurting me. Hey, that's awesome. That's a lot of fun. This is all sarcasm, as I say, like... Tooth pain is fun. But yeah, I don't know. So I'll get checked out on Tuesday. Hopefully everything's fine till then. Number 5. Write out the implicit equation. So let's take a look at some of that right here. Let's go over, take a look. Some lidocaine. You can't get that stuff normally. Can you, Trace? Can you go buy that? Because I mean, I'm saying I might just, because that's what they put on your gums, right? If I could go buy that, I'll go buy all of them. If I'm allowed to. I don't know if I'm allowed to go buy that stuff. Write out the implicit regression equation. Mubot, you took that long to add in those points. What you doing, Mubot? Write out the implicit line for when your quantitative variable is equal to 0. So, implicit equations. We actually almost got to logistic today. So we're doing some logistic back there. So let's write out, let's see what model we have stored. Hey, Tyler, good to see you. Tyler, I actually have it ready. Tyler, if you stay a second, I'll show you it. I think I've got it ready. I'm not even joking. I think I've got it. Tyler, hang out. I'll show you that next right here. I just haven't rendered it. I gotta, and it's ready. Like Tyler will, actually, I think maybe I did render it. Stay for a moment, Tyler. Next segment, I'll show you that. We'll premiere it live here if you want. Tyler, you get to call if we get to premiere it live here. Sometimes lidocaine is, but I don't think it'll be the same as the inject. Yeah, I know, right? That stuff they do is like, oh, I don't feel anything. Maybe I should stop touching that area. Probably a good idea. Let's go ahead and make a model right here. Awesome, Tyler. So good to see you. And we're just going to make height, weight, gender. Boom. Don't steal my variables. So the important thing to know when you're writing your models is how to write the equations. So if you look at the output right here, you've got intercept plus this times this, plus this times this, plus this times this, and it just goes through algorithmically. So we call it the double dollar sign to call LaTeX code. LaTeX writing is just a format. And so we're going to take this right here. Nope. This plus this times this. You're just algorithmically going through and adding them in and just adding in each one. Make sure if there's a negative to add it in. And that is the indicator variable. We are predicting somebody's height. Nice and easy right there. Height equals. Now, always make sure you can see what you're looking at. You can always use in Microsoft Word if you don't like this kind of thing right here. But, whoa, what do we got right there? Whoa, did some craziness on the screen. Make it nice and big so we can see. So here's the equation. Height of an individual is equal to this plus this times this. Remember, this is just our output. Let's put it on the screen. It's just the output right here where we're predicting height. How do I know we're predicting height? Well, I wrote the equation this way to predict the height. And also, you can see right here, we take the intercept, place the intercept here. Then we go this coefficient for weight, and then we times it by weight. And then we have right here gender male, and we have this right here. Now, if you want to solve an implicit line, you can solve for certain values of variables. That's what an implicit line is. So an implicit line is where we literally go in and plug in a value. And what's really great is if you plug in 0, which we could solve for individuals who are male or not male also. I'll talk about that here in a second. But if you plug in a value right here, all you do is say, well, for individuals who have weight equal to 0, here's what we would get. And since it's 0, it's just going to take off, and you're going to get the following equation. So I just like doing that right there. So now we have the equation for individuals who have a weight of 0. A lot of times, though, we usually solve for the categorical variable to solve out like a gender male line and a gender not male line. So the gender male line here So 5 deals with the and if it deals with interactions, which I think you might be correct, we just throw on an interaction term. This is going to change coefficients. Darn you, coefficients. So now the coefficients are going to be different. We just go down here and we algorithmically go through again, and we just do this plus this times weight. See, we're just taking the same sort of thing. And there's a different coefficient for gender male right here. And now we have an additional term, which is going to be the interaction term. It puts a colon right there because it's showing it's just the interaction. We are going to change that to a star so we can show that it is being multiplied, which is what the colon is saying right there. And here is the equation above my head right there. So we have height is equal to the intercept plus the coefficient of weight times weight plus the coefficient of gender male times gender male, which is an indicator variable. The variable is gender. How do we have to show, as long as it's decently shown. I've gotten through a third of the grading for the last assignment. As long as you decently show things, I'm pretty nice on, I hope people think I'm pretty nice on the grading. I think I'm pretty nice. Probably everyone who grades things thinks they're pretty nice. But if I'm like, where the heck did this come from? I mean, I can usually check. You want to make sure I can see your summary and stuff, and I can kind of look at it. And unless I see something that's way off, I'm usually not going to like, if it looks close, I'm going to be like, yeah, that's right. But, you know, just having the equations, showing enough of the work that it's pretty clear what you're doing. You don't need to show like every little meticulous step, but the more you show, the better, generally speaking, unless you're literally showing every little thing. There's a point at which it becomes too much. A few people got hit with excessive output. See if you had excessive output. If you ever show like a page of stuff you don't need, I'll take an excessive output off. So don't let that be you, especially if you saw you got hit with excessive output last time. If you were to solve here gender not male, you would just solve through here and look, you've got this times 0, so this literally goes away. So we're solving a line for an individual who is not male, and this is this times 0. Well, that goes away too. So this would be the regression equation for somebody who is female. This is the regression equation for individuals who are female. Now, the regression equation for people who are males, we can actually solve kind of easily because we can take the intercept, and the intercept is just going to have this constant value added to it, 4.811. 4.811. And we get the following value here. Because we're literally, if we go back in time, instead of plugging in 0 for gender male, we're plugging in 1. And this right here is just a constant value which gets added to this over here. So if you were to take this and multiply by 1, you get a constant, and then you just add the two together to get the new coefficient of the intercept. So we're just adding like terms right here because that's just a constant value. Now we have to look where there's other values that are similar. We have right here times 1, anything times 1 is itself, and then we have this times weight. So these two can be, just look at this right here. These two have the same sort of thing, and if you notice in the output, this is going to change the coefficient of weight. So when we go right here, we can just take this coefficient, add it to this one, to get the new coefficient of weight for the gender male line. And once again, this changes the slope of the line here, and that's what we're doing. How does that look right there? Does that make sense? Is this making sense right here? How to solve implicit lines? You just solve for a value of X. You say, maybe these individuals are male, maybe they're not male, maybe they have a weight of 0. And so you're going through here and showing that you know how to solve implicit lines. That's the goal of number 5 right here, is do you know how to solve implicit lines? For 5B, are we just choosing variable gets 1? You just choose anything as long as you just specify in 5B, write out the implicit lines. That's just a random one right there. Write out the implicit, another random one. Write out the implicit lines for a value you've decided. Make sure to give the value and then show how you found this. Show the algebra, like show some of the work. Make it clear you know how to solve implicit lines. I think a lot of people when they get the test have no idea what implicit lines are. And we've been talking about them a lot more lately, like solving the implicit regression equations. It's great with binary indicator variables, but if we have 3 or more categories, yes, yeah. If you have 3 or more categories, like here's a 2 or more. This one only has a 3-level categorical variable. Handedness is not a great variable for weight, but here we go with an interaction where you can see here the differences in the slopes, and none of this is statistically significant, although we do need to run a partial F. Okay, let's run the partial F on the interaction. The interaction is not significant. It actually has higher p-value than the differences in the slopes from the reference slope, which is ambidextrous. How many more? One more on Monday. One more assignment on Monday on logistic regression, where everything changes. Logistic is when everything's going to change on you. Your whole world changes. Be careful. Logistic is different. It's similar, but it's different. And this interaction right here is not statistically significant. And one of the great things about our code is we can actually view this. We should be able to view this. That's a logistic right there. You can see the differences. Let me decrease font size. Oh, wrong button. Playing the sad music. I shouldn't play sad music. I feel like something bad's going to happen. Less sad music. There we go. Could you write out the function for an interaction model? Keep getting an error. It says my model is a list. William, are you on Discord? Are you Tony? I think I know you're on Discord. Can you send me it on Discord? Send me a screenshot. So you can see the interaction here, which is not significant. The lines are not perfectly parallel, but still it's not strong enough to create an interaction that is statistically significant. Probably the variable itself is not statistically significant. If we don't have the interaction, we'll just see changes to the intercepts. So we take out the interaction right here and we just go back to a non-interaction model. Well, wow, look at those changes in the intercepts. I mean, that is about as high as a p-value as you'll ever see because those intercepts are basically overlapping. As in there's basically no impact when compared to two individuals who are otherwise identical, have the same weight. Their predicted height, as you would expect if you're left or right-handed or ambidextrous, really has no impact, and the overall impact is done via the effects test of handedness because the individual variables themselves are just the difference from the reference level, which they're not significantly different from the reference level, but the p-value right here is the overall impact. I'll see if assignment 9 asks for model with one cover. Just use cut. There we go. Oh, that's the message. I'm back. What did it show? Oh, we gotta show the thing. Okay, let me go find this. After William's question for 4B, when you say you have 7 categorical, does that mean you have... I think, did I say a 7 level or did I say a 7 categorical variable? Ooh. Did I get my grammar wrong? If we have a 7 level. If we have a 7 level. So 7 level key right there. And let's make a premiere on the channel. No, it's the wrong video. Oh, it's in After Effects. That's where I made it. Cancel. Okay. I wasn't able to get into your BA's 320S this fall. My advisor pushed me into the 8 a.m. class. Then I told her I couldn't really do that. She told me we're not allowed to. Ah! Well, I'll be streaming online, Tyler. So levels would make it different. Well, a 7 level categorical variable is like weekday, like day of the week. And you're hearing some 320 right now, Tyler. So yeah, I mean, this is, but you're just feel free to hop into any of our streams. I think I completed this. Let me double check. I think you're in this one. I think there's like a few things I need. Yes. Okay. Can you hear the music over this? Okay, wait. Did I not render this? Let's see if it's ready to go. I'm going to try to render this right here really quick. So does that make sense, Trace? Levels means like a 7 level categorical variable is like day of the week. And so I'm going to try to render this right here as we speak. So day of the week would be a 7 level categorical variable. And did I miss? And I think William's sending me his stuff, right? I think he just did. I'm going to see if I can get this rendered. So many issues with rendering. rendering stuff. Okay, let's just see what happens. Output to new epic. Okay. Let's just see what happens. 2 footage files are missing. Sure. Is it rendering? I'm just breaking stuff. What have I done? I think it is rendering. Let me stop. Pause. I think I got really far into this and there was a problem. Okay, now I've like crashed it. Exactly, Trace right there. I'm having an issue with this. All right, here we go. It's saying I'm missing something. What is it missing? Oh no, it's all right. I wanted to get here. I'll go to the main screen. I wanted to, it's a big file, and so I added in some new videos and stuff. Brian Stevens as the Joker. So then Tyler right there you are. As long as I have your alternate universe Brian is sus. It's me with a beard. Stats to 1. It's saying I'm missing a file. I have no idea what it says is missing. But I worked on this, got it all created, ready to go. And so yeah. Yeah, I'll have to see why it's not. I thought I rendered it. Is it Matt over here? Oh, Morty the Bunny as our TA. I added in Morty. So Morty's here as the TA. Why will this not render? I don't know. I'll figure out what's going on with it. I'll get it rendered up. But it should be good to go. So you've got Morty. You've got random references. You got Brian as the Joker. Tyler as Dad Bod Thor. And then you got alternate universe Brian is sus. Yeah. Oh no, we didn't get mullet Brian. We got man bun Brian. And then I think it just says stat to 1 right there and it smashes. So I'll have to look into I thought I rendered it. I'll have to look through my files and see if I rendered it. I don't want to save any changes. I don't know what changes I made to that. Let's go back here. Morty's so cute. Morty's always cute. Let's go back here to the main screen. So this is what happens when Brian tries to learn how to use the Adobe Suite. He fails. No, that's been on my list, Tyler, to get that finished up. And then I've had some time over some weekends to like work on stuff. Those are like my fun enjoyment projects. And then just like sometimes I don't have time. Let me see. I think William sent me some stuff. Here we go. 9 to save into 9. Wait, what is the variable 9? 9 is my model. But the variable name 9 is your Y variable. Oh, but there's no LM on that. So I don't know what you're trying to predict. So Y variable name, and then you need an LM on this. Close, really close. Great working on this, everyone. So need the Y variable name right there. I can't take no worries about the screenshot. I fixed it, never mind. I think William's getting it fixed right there. I just saw that too, William. Alan, so good to see you, Alan. We're talking about Discord today. We're trying to get some people. We're going to start 474, 475. Alan, are you taking 475? So good to see you, Alan. What additional questions are there right now? I'm a little out of it today. Toothache. Just got my dentist appointment made for Tuesday. So hopefully on Monday I'm all right. And Tuesday I'm all right. And then I'm going to get my second COVID vaccine on Friday. 476 and 479 in the fall. Can you talk about 4A? Yeah, let's go talk about 4A. 4A. Let's go talk about 4A. Let's do it. So right here, explain what the coefficients of indicator variables change in the model without interactions. Here we see. Oh, you're in London? Oh yeah, you told me about that. Congratulations on your internship, I believe, right? Awesome, Alan. Yeah, just chilling out with Stat 1 at night. What does it look like we are changing without interactions? Without interactions, we're changing what? What has changed between these models? It might not be so apparent here. It'll be more apparent if I do this. What is changing between these models? No. Yeah, you can see it. Now, if you add in an interaction, if you throw on that interaction, that's where you change the other. Oh, man. We're not seeing much of a change right there. Now you see the... Really? Now you see the change in the slopes. But if there's no, and I'll vanish here, just with the interactions, or just with the indicator variables themselves, we just see intercept changes. With the interactions, you see the slope change. So you can see a change in the slope with the interaction versus when we do just indicator variables. Can we estimate interaction models without main effects? Yes, we can. What do we call that? I'm going to throw 100 points if anyone knows how we can estimate interaction models without the main effects. Who knows? We've been learning this in class. Explain how to do it. We can do it, and I'll do it here in a second. What would we call this, and what's happening when we estimate the interaction coefficient without the main effects in the model? Drop one's going to do a partial F, and that will tell us the significance of like dropping out certain variables out. But so what they're saying is they only want the interaction in the model. They don't want like, yeah, I think this will give away the answer, which is what I want to do. Keep thinking. 100 points on the line right here. They are saying, don't give me. Do I have an interaction small? I don't have interaction. They're saying, I only want this. They're saying just put this in the model. Don't put the main effects. What are we doing when we just put the interaction and we don't put the main effects? So that's the key to this question right here. It's a good test question because we've talked about it. I'll drop a hint here in a second. I'll drop points to 50. Oh gosh, what am I doing? So if they're saying just, and we were talking about this today over here. I was on the first set of notes. Dang it, so it's not. I'll draw it again. So this is called what? When you have the interaction. Yes. Preston, everybody, great job. Yes. Showing off that knowledge right here. Love it. Great job, model hierarchy. And that's how you get out of model hierarchy. So I'll show it. Let me make it a little bit bigger. To violate model hierarchy, which is, you don't have to hold model hierarchy. Model hierarchy just says right here, and you see you get the 2 right here. So it's giving, interestingly enough, when you violate model hierarchy with the interaction, it's giving you the slope for the female line and the slope for the male line, or the interaction. So yeah, it's basically doing a female slope and male slope. And then there is no change to intercept. So we're just seeing the female slope has its own, or the female line has its own slope, and the male line has its own slope, but there's no change to intercept because they both have constant intercept. So literally this points to, what does the interaction change? So put it in the chat again. I'll throw another 20 points on this. What does the interaction change? Because all we have here is the interaction now. So this literally shows us that the interaction is just changing the what, which you can't really see right here. The interaction is just changing the what, because hint, it's connected to this variable right here. It's connected to this. The interaction, which is shown right here. Well, the indicator will change whether the interaction is happening or not. So there's the indicator. But the indicator, or the interaction, is changing the what of the line. The interaction changes the what. The interaction changes the what. Well, we violated model hierarchy, but what's different? This is not a, yep, slope right there. The slope. The slope of the line is changing right here. Good review, good practice. Good practice. It's I always want you guys, gals, and everyone, to fish the answers out of your head and be like, what's changing about this model? And the interaction changes the slope. What changes, here, let's go back. What changes the intercept about the model? What changes the intercept? What by itself, which you can see right here, and you can also see the model I've constructed, what by itself changes the intercept, which is kind of the original. How do you do interpretation of intercept with the reference level? Oh, interpret the intercept. Yeah, that's the previous one. Here, we'll do that next trace. Great question. Here, I'll interpret this intercept. So the indicators change the intercept, right? So when you think about, and this goes back to like the homework question, when you think about the intercept right here and what the intercept means, and we're currently viewing the model, I believe. Random intersects fixes slope. Ooh, wait, what's this about? Can you explain more detail about random intercept fixed slope? The explaining rare detail, because I might not know what you're talking about there. That sounds like something new to me. Maybe a thing I don't do, but maybe explain it and I'll know. But yeah, you bring up so many great things and so many great topics because there's a lot to learn. When you look at this value of the intercept, it is rather meaningless for distinctly one reason. The reason the intercept here is meaningless is why. We're talking about individuals. Oh, mixed model. Yeah, classic stuff right there. So we don't do mixed models here. I'm sorry. No, nothing wrong with those. But I mean, it's just we've got so many topics. You have to be like, okay, we need this, we need this, we need this, we need this. And then we want to get to like, I'm sure you know stepwise model. That would be the next thing if we had 2 more days. I could do stepwise models and variable selection. So I'm sure you probably know about that stuff. But we'd be doing a stepwise model and forward, backward selection, all that good stuff, and all possible models. A lot of classic stuff right there. When you look at the value of the intercept right here, you'd be saying among individuals who have a height equal to 0 and also gender equal to male. Because what can indicator variables only take on? Indicator variables can only take on the value of what? An indicator variable can only take on the value of what or what? Oh yeah, random forest is way better. Like also boosted models. Yeah, that's kind of what we go towards in the exactly. Look, man, I tell you, they know their stuff right here because this is classic stuff right here. Like indicator variables can only take on the values of 0s and 1s. Also, random forests are amazing along with boosted models. So when you look at like gradient boosted models are going to be some of your best stuff out there in data mining. Which hey, check out some data mining officers coming up here in a week or so. We'll be going into we'll be kind of starting over again, getting a little bit of base knowledge, and then going into data mining as time progresses and time series stuff. So the model right here, when we talk about the intercept, it's rather meaningless. To understand what the value of the intercept means, we're actually talking about the intercept for the female line. I think we drew this out. I don't know if we have that drawing from yesterday still. Oh, we do! So yesterday we drew this out. The female line would go all the way back here. And this is the coefficient of the what variable. This difference of 5 you notice right here is the coefficient. Did we make the same model again? We need to predict weight, or we need to predict height. This coefficient of 5 right here is what? This coefficient of 5, it's the t between making the t-test? Kind of. It's almost a t-test. If we do it by itself, it's a t-test. If we include the one variable, it would be. If we go right here and we just do... If we do that, we should get the t-test value. And we could confirm this by doing t.test. So many good answers right here. We should be able to predict height, gender. I rarely use this. And the t-test comes back with a t of negative 27. And there you go right there. 27 point... it's slightly different. I wonder why. Why is it slightly different? And it is why that's slightly different. Maybe it's not carrying enough decimals. Let me look at the associate function on this. So she does it a little bit different way. It's going to come up with the same differences between it. But when we look at this right here, this difference of 5, I'm doing a different model. My brain is just breaking to everybody. I'm sorry. Oh, because I changed my model. This difference of 5 you notice right here. This difference of 5 you see right here is the differences between the whats of the lines. That difference of 5, which is the coefficient of the indicator variable, is the difference of the whats. And please note where I put this. I mean, it's going to stay, but you could describe it as the difference of the whats when you write the equations. This difference of 5, which I'm putting right here on this specific value, when you look at your two lines, is the difference in the intercepts. So great job, Kirsten, right there. It's the difference in the intercepts. So you can see here that the indicator variable only changes the intercepts. And we can visualize this again, just so we can see what's going on. And you can see it's only changing the intercepts. And so now, if we were to throw on here an interaction between the two, we will see the changes in slopes. Now, this interaction is not statistically significant, which means you really don't see a difference in the slopes. And you'll often see something like this for very high p-values on interactions. We don't maybe see much of a difference. Once again, you can visualize it to see it. If it looks small, it might not be statistically significant. If it looks large, it might be. We've done a lot of different ones where we've seen stronger interactions right here versus weaker interactions. But once again, always look at that p-value. The p-value is the true way to tell, because sometimes you can have a very large sample size with very low uncertainty. So there's a lot of considerations to have. You don't just look at it and say, not significant. Look at the p-value. Although it does confirm with this one when we look at it, like, lines are still basically parallel. Because once again, the interaction right here should be changing the slopes of the lines. And it is, but just barely. The slope of the line originally is 0.032. But for the male line, it is 0.032, 0.033, because that's what that should equal up. So the male line has a slightly higher slope, but it's so small it's hard to see. For this question, why don't you use the reference level in the model if for this question, why don't you use... For which question again, Trace? Here, I'm going to put a cut in the video. Cut. Which question used the reference level? For this question, why don't you use the reference level in the model? For which question specifically? 4A or 4B? Female will be the reference because it's first alphabetical. And so... And it's just arbitrary. It's just arbitrary. This 2C... Yeah, so... And let me look at 2C. I think 2C is interpreting... Oh, why don't you see the reference level in the model? Yeah. For 2C, why don't you see the reference level? The model just... Because basically the reference level is only when the indicators are set to 0. Does that make sense, Trace, right there? The reference level occurs when the indicators are set to 0, so we don't report a coefficient for the reference levels. The reference levels have like the value of the slope and the intercept that are the original values, like they're the reference. And then the indicators are the difference between the reference. Like when we do the indicator variable, we're saying, well, the intercept for this group is this much higher. When we do the indicator within interaction on the quantitative X, then we're saying the slope for this variable indicator is this much higher, this level of a categorical variable. Does that make sense, Trace? We don't see the reference level because it does not have any difference from itself. Every indicator indicates how different things are from the reference level. The reference level is pretty much the original intercept or the original slope. Awesome, Alan. Have fun in London, man. Awesome stuff. Tell me how London goes. Man, I want to go to London. That'd be so cool. Quick clarification, Q. Do we only plug in one value for one of the X's for 5B? Exactly. Or a value for... Nope, just one. Like you could solve... You want there to be some sort of unknowns in an implicit regression equation. Implicit regression equation just means you're going to plug in values and create a line that is based on certain values. So you're going to, like make a male line or a female line or line for individuals or predictions for individuals that have a weight equal to 0, and then you can solve from there. So you usually want some unknowns, but it kind of sets something. It helps you kind of graph stuff too, because if you have less unknowns, you can put it into a lower dimensional space, and then you just show different lines. So here, I'll show you another type of implicit lines, just so we can talk about implicit lines here for a second. Talk about implicit lines. So we didn't do this, but you can... No, we did this. We already showed this. This was a Wednesday or so. If we are predicting something like height, classic, desired weight, what changes about the intercept when you interpret it for the slope? It is two individuals, otherwise identical. Still setting things to 0, but then just make sure it's not that gender male equals to 0. It's that somebody is not gender male. So you wouldn't say when gender male is equal to 0, because that just doesn't sound like... It sounds too mathematical. it'd be for individuals who are not gender male. Does that make sense? So you're saying when you interpret the slope, you're saying the indicator variable is 0, but you're saying what is it? An indicator variable literally means someone is this or is not this. So trying to make that clear to especially the person you're speaking to by saying this person was not a male. So for individuals that are not a male and have a, like this one right here would be for individuals who are not male and also have a weight equal to 0, we would expect them to have a height of 60 inches. The intercept goes down here. So individuals who are not male, which is female in this model, who have a height or have a weight equal to 0. Yep. And so you just don't want to say when gender male equals 0 because, I mean, it's mathematically true, but we want to go in logistic. It's for Monday. Yep, we've done some logistic today. We just didn't get far enough in. You're right, and that's a big thing too. This model was created only from gender being collected on 2 levels. So it's very important how we collect variables. So we want to make sure, especially if we were to do a survey like this nowadays, we would want to make sure to include non-binary and stuff like that to make sure we can actually put that in here. And so non-binary would not be the reference level. And if we include asexual, that would be the reference level. Wait, just making sure. Sorry, once again, I'm hoping I don't have a fever today from toothache. Hope everything's fine through the weekend. Work on a Kaggle project online? Yes. I have a life advice question for Ryan or anyone looking to. Do you suggest trying to work on a project that, oh, that's what they're, yeah. Yeah, I think Kaggle projects, actually, yeah. What's Kaggle? Oh, man, let's talk about that here next. We're just talking about implicit equations for a half second here. Kaggle is a great competition site where they got tons of data, and you can literally do them and then talk to companies about, like, I worked on this Kaggle project. What are you mad about? Desired weight not found. Desired weight. Kaggle's got so much cool data. So let's go look at those implicit equations. And here you are. Oh, did I not include an interaction? Let's go interaction on this. So what this is doing is it's solving out for different values, the 10th percentile, the 50th percentile, and the 90th percentile, just so we don't get extreme outliers. Trace is giving some great advice in the chat right now. We have here the lowest percentile, the medium percentile, the 10th, not the lowest, the 10th, the 50th, and the 90th. Dr. Petrie wrote this code so that you don't get the extreme outliers. So you're not seeing a line just go crazy because someone put an extreme value. So it's almost like a trimmed version of the smallest value, but it's just a smaller value in the data set. And then we can get implicit lines. So all it's doing is solving what is the 10th value of weight and then creating the line and letting us see right here. Great job, Trace, right there. You know what? We'll go to it. Let's put another break. But those are just some implicit lines solved out. As in, like, you literally go, I'll show you how to do one. You take your equation. And there's our coefficients. They got to be crazy here, of course. I need to change my decimals again. So you go down here. You put in your dollar signs. And we are predicting somebody's height. Height equals this plus this times this plus, we'll call it DW. When you're in trouble, call it DW. This times this. Oh my God, it's got to be negative. Plus this times this. Okay. So what you have to do right here. Awesome. Great job, Preston. Okay. What you have to do right here, or what it's doing for us in the background, is it's going to go in and it's going to find the 10th percentile of weights. So it's going to go quantile of weights and go to the 10th percentile. So it's 117. So it goes here and it literally plugs in 117, 117, and then it solves through. So we just take this right here. That's going to be added to the intercept. So we go here, add this to the intercept. There's our new intercept. And then we're going to delete that off because we just added it. And then this is desired weight right here. So hopefully quantile, yeah, it's not quite, I haven't done much quantile regression. I actually was talking to someone who was doing that for their graduate work. They're doing a PhD in they're using quantile regression. These are the implicit. Maybe it sounds like quantile regression a little bit, but it's just basically solving the lines for certain occurrences. I haven't done much quantile regression. Oh, Trace, I'm so sorry, man. Maybe I'll do another big point thing or something. I know. I try to put some new goals on there so we can reach some new goals. And so here's the new. I put high goals, Trace. I put things for you to reach to. You got this, Trace. You're going to do fine, man. You got this. And so that is our new equation when something has, or for individuals that have a weight of 117, which is the 10th percentile, and that's how these lines are being calculated. Look, we just have the predicted y equals intercept plus coefficient of slope times variable, and that is over here, shown for us here on the graphic right here. And did I mess up? The coefficient should be negative. No, it's desired weight. Good. For weights of small, it should be positive coefficient. Okay, I thought I made a mistake because I was like, I'm seeing a positive slope. You're doing great, Trace. You're doing great, man. You got this. And you can see the blue line right here is the equation that I've written. So it should go down here and hit 47. I annotated some decimals. What else was I going to say? Oh, no. Let me reappear. Excellent work, Trace. Trace, you got the 20,000. Maybe I need to make it 20,000. I think, Trace, you have the highest points. Let me look at the points. Feeling pretty good about the exam. That's awesome. Great job. Put a little music here. Gotta stop touching my tooth with my tongue. Currency. Trace, you're the top point getter. Let me change it. I gotta finish syllabi this weekend. I can't be in pain. I can't be having problems. Trace, I'm putting it to 20,000. 20,000, Trace. 20,000 right there. I don't think either one's more difficult. I think it's just it's going to be coding. I think they all overlap. Since someone should get to it, right? Someone should get to it. So you'll get to it, I think, next week. And then I don't know if anyone else will, but I mean, you've been going for those points. So, hey, that's how it goes. You keep going for the points, then I just try to adjust. I don't want to make it like, oh, no one got to the highest level. The highest level is 10 billion. But what was I saying? Losing my mind. I don't think either one's really more difficult. I think they're both just, an upper level class. I'm still working on making my 475 material. Luckily, one of the instructors wrote some amazing slides. I'm going to be using her slides, Dr. Chung-Hoon Lee, who's leaving us, unfortunately, but honored by her work and honored by her being a colleague. And I hope to hear amazing things from her as she's going up towards New York, I think. My area, New York. But no, we're honored to have her work here. And I understand why another university is like, hey, you're great. We want you working here. No! Taking our best educators. Don't do that. I don't know where the screw came from. Just fall from the sky? A little tiny screw there. I don't know what's going on. I will say that, shout outs to my department, Dr. Galbraith and everyone, is that we really have such a great department with... Oh, it came out of this. Everyone cheers everyone on. Everyone works together. Everyone helps everyone out. And yeah, it came out of this. We really are a team. And he's really helped make that. And we were interviewing for department heads a while back. I'll probably be forcing everyone in neural network. Yes, exactly. We'll be doing some neural nets. I'm just gonna break this. We're doing some neural nets. We I've liked all my department heads, but when we were interviewing for new department heads, I was really worried because 2 of the 3 people, not that I disliked them, but I was like, I don't know if they want, the department head has a vision for the department. And I was like, Dr. Galbraith came in. He was like, hey, Brian, I see you got this YouTube channel. You're doing this whole online thing and you're really great at it, blah, 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 blah. No, maybe one day after, I learn from Dr. That'd be far in the future. You're talking, 15, 20 years at least. One, I don't have a PhD, so that's probably not happening. But I would never be able to, even after more experience, be able to meet the caliber of what Dr. Galbraith does. 1, he's got the experience, and 2, he's got the drive. And also he's such a great person. I need to get my PhD. I gotta figure out what to get it in, and gotta get that PhD. But Dr. Galbraith has set an amazing example. Well, Dr. Noon was a great example. Dr. Gilbert was a great example. Dr. Mew was also a department head, not while I was working under the department, but he did great, and he still works for our department. Awesome. Other ones do work for it too, but Dr. Galbraith has really just set the bar very, very high. And so just what I do is not department head related. He does a lot of like meeting with people, internal stuff. I hope too. I mean, if you know, yeah, I hope to get my PhD. I hope to one day. I've done 3 PhD courses. Maybe my last one I got an F in. Not saying anything, but you know, maybe I was like focusing more on my students than my own studies, which I sometimes do. But my students come first. I mean, well, you know, like myself and my fiance come first, but the students, in terms of when I'm giving help, I'm going to focus more on what they're learning than I'm going to try to get A's in my classes, which may be sad, but if I'm failing my students, I'm failing at my job. This is my job. My education is important to me, but my job is to help you learn material. So you come first when it comes to education. But I hope to get my PhD. PhD is no joke. Like I'm not saying any other degrees are jokes, but undergraduate, it's pretty easy. Well, let me say this. High school, I didn't work at all. High school, I was like doing nothing. I was like sleeping in class most days, and somehow they let me pass through high school. Probably did myself a disservice right there. College, I worked some, you know, some all-nighters, some like, I was like, wow, you gotta actually work to get grades. You gotta actually study. They'll fail you like more often than they did in high school to me. Graduate school, I was like, you know, this really matters now. And I really focused in, and, you know, we were turning in like projects and stuff, and we were on like team groups and stuff like that. And if you're not pulling your weight, people are like, hey, what are you doing? We need this yesterday. And I'm not saying they would say that to me, but you know these people a lot better, and it feels more like a job. Then when I got to PhD, I was like, where's my group? Where are we working together? Like, no, PhD is like, you're learning this on your own. Like, you're going to go home and read this textbook tonight, or read this, you know, article. You're going to like spend the weekend, 4 hours of reading, 3 hours of research, 2 hours of coding, or maybe 5 hours of coding. And then you're going to stay up till 3 a.m. Like, one of the craziest moments to me, I still remember this. Like, my fiance looked over at me, and I had been looking at the screen for like 20 minutes and just like staring. And she's like, are you okay? And I was like, I just don't get it. She's like, what do you mean? The way how I learned statistics. See, that's the hard thing is, and I was just like, I don't get it. She's like, what do you not get? And I was like, I just don't get it. I don't understand it. And it was, I think it was some partial differential equations and all that. It was some very high level understanding. You might be like, PDEs, those are easy. Well, not for me. I'm not good at partial differential equations. And I'm not even good at ODEs. But I just was sitting there and I was like, in despair. I was like, I just don't get it. And I don't really, I mean, like if I walk into which I should have walked in more often and said, I don't get it. But it's tough. They expect you to be at a very high level. They expect you to be like, they expect you to know it. And at times I just felt like I was falling. I just didn't have the prereqs. ODEs are not that difficult. Just got to practice the problems. Yeah, I should get my ODEs down. It's tough. So at each jump in education level, I think it was there was like some double partial integrals in them and stuff. It was pretty crazy. I was looking over it and I was like, I just don't get it. Just, what don't you get? Just all of it. I'm just reading this and it's bouncing off my head. It'd be like looking at another language. Well, what I do is more of the master's level. I'm a very applied type person. Thank you for the compliment. What I do is very applied. I know how to apply this stuff. I know what the theory of what I'm doing is. But when it comes down to a lot of the mathematics, like the eigenvectors, the eigenvalues, the linear algebra, I know a good bit of it. But I mean, the understanding at the PhD level is like not how to drive a car, but how to build that car from scratch. And so, the PhD is no joke. It's a very, very, very high level of understanding, and they expect you to get to these levels and then contribute to your field. So, and unless you're just going to like a diploma mill, don't just go to a diploma mill. Get a great degree that you're getting paid to get, that is going to help you get a job you want or going to an area you want. You can do social or applied statistical. You know what? I might do something like that. And my background's in psychology, so maybe one of these days I'll apply to like a psychology PhD again. I'm not trying to. It's just the more mathematical a field, I just don't have that math background anymore. And I do have a great interest in psychology, so I'm not being like, oh, you never heard of diploma mill before? Yeah, diploma mill is a term. And I say this not jokingly. Watch out for things like that. That people who just want to take your money to get a degree. I do believe in education. I think education is super important, but there are degrees offered that just won't really get you anywhere. Like ITT Tech just had to do a big settlement. Like literally, if you're like, Brian, you're trashing on things. No. ITT Tech just literally had. I don't know if it's the whole thing, so I'm not trying to trash them. This is a real story right here. So, you know, I want to be an advocate for students. I want you to get the best education and learn things valuable. But thousands of defrauded students are getting their loans erased. Awesome, Trace. Good seeing you here, man. But, yeah, if some place is saying, oh, we can do this, that's a pretty interesting education system. And you just have to, I don't know how your guys is, but if you have questions about ours, just let me know. So, yeah, I don't know if this goes for all of ITT Tech, but there's the article. Lest they get me for defamation, they can go after NPR for defamation. That's where I heard about it. Just happened here, June 16th. So just a week ago or so. But you don't want this. You want to make sure your degree is going to be useful in the future to you. So focus on that. Focus on doing something you love you're doing. We're just going to get random ads. So let's go away. $444. J. Jonah Jameson right here. That's J. Jonah Jameson from Spider-Man right there. But yeah, that's my advice. Is find something you love doing. And it's like that classic, like find something you love doing and you'll never work a day in your life. It's true. I love teaching. I love here streaming. I love talking to you guys and everyone. But I'll probably head off here in a moment and get some lunch. Got that dentist appointment. Yes. Doing the adult things, taking care of myself. Watch on Tuesday, my tooth doesn't hurt anymore. I'm like, I don't feel any pain anymore. I should still go to the dentist. Hopefully it's a good dentist. I just found like when I have first available appointment. Maybe that's not a good thing. Well, with that, I'll start looking at it. I won't put words in your mouth, but I feel like the PhD is overbearing for what you enjoy. Yeah. Oh, thank you. And wait for children. Wait for children what? I don't know. Oh, yeah, well, it all depends. I mean, it's just what I'll say this. For me, yes, waiting for children was the choice I made. But for you, that might not be the choice. Just the general you, the global you of all individuals that exist. If you really want kids, then have kids and make sure, try to make a plan for having the kids. But definitely it's a lot harder with education to have children. Not saying you can't do it, but I'm sure, I've had many people who've been taking classes with me who have kids. Because put it this way, I think your kids should come first before your education. So, and it's tough. You got due dates and stuff, and maybe your kid's working on an assignment. So your kid says, hey, Dad, I'm working on this math assignment. Can you help me? You're good at math. And you're like, no, I got to do my work. It's tough. So, yeah, it'll add. Like, the easiest time to do stuff is generally when you have less responsibilities. You're welcome. Yeah, it's just chill. I might just be giving the normal advice anyone would give. Thank you, Preston, for listening. And throw out your thoughts and your advice. But I do say, if you want to have kids, have kids. Like, do you? That, I have many different family members who have chosen many different paths. Some of them have 3-4 kids. Myself, I have 0 kids. They're happy. Some people say you need kids to be happy. I don't think you need kids to be happy. I have no children. No children have I, except for Bun. Morty. We might have another bunny here soon. But, if you, I just will not critique people for, I'm not saying anyone was doing that, but I just believe in you choosing your life and your choices. So do that. I think it was a villain who made the best. The best comment ever in a superhero movie actually came from a villain. I've been meaning to make a video on this. And the comment was made by Green Goblin. We'll end with this. He was holding Mary Jane, and he said, We are who we choose to be. And they let go, and he said, now choose. Let go of the children too. But I just want you to think over that quote. Probably one of my favorite quotes ever. Oh, thank you. I appreciate that. Maybe one day. Who knows? I'm an uncle right now. But I'm going to leave you with that quote once again. And I just want you to think over it. We are who we choose to be. Now choose. Bye for now, everyone. Bye.